So you were killing yourself trying to do D9, and I wouldn't do it for you in class, and so here you are looking up the answer. How in the world did he figure out this answer? I told you ahead of time that this was going to take 5 equations. It really takes 3 equations, but you have to do 2 of them 2 times. So we've got that, and we've got a couple conversions to do. First, I'm going to make a little map, or a little chart, a little graph. So the car has an acceleration of 5 meters per second and a maximum braking acceleration of 8. The speed limit on the road is 60 kilometers per hour. What is the shortest legal time needed to go from one stop sign to another 300 meters away? Well, the first thing we have is 60 kilometers per hour. Now, that's not going to cut it because everything else is in meters or in seconds or in meters per second squared. And so clearly we want to switch this to meters per second. So first thing we got to do is take that 60 and divide by 3.6. When we do that, we find that we're at 16.666. And that is going to be our velocity. So that'll be our final velocity for the first part. So we're going to start off at 0, and we're going to speed up as fast as we can until we hit that maximum speed of 16.66 meters per second. Then we're going to cruise along for some indefinite time, and then we're going to slam on the brakes, and we're going to try and stop. So this is kind of the graph of our motion. And what we find, of course, is that we really have 3 different sections here. What we need to find is how long does it take me to go from 0 to 16.6 meters per second at that acceleration rate of 5 meters per second squared, and how long is it going to take to go from our 16.6 meters per second down to 0 again at the end here when we are braking at, of course, this would be a negative 8.0 meters per second squared. So again, here I have a V initial here and a V final here, or I have a V initial here and a V final there. And if I just have V initial and V final, and I'm looking for T, and of course I have A's for both of these. That would be an A here and an A there. So I'm just going to use the acceleration equation, solve for time. So time is going to be VF minus VI over A. So I'm going to do that 2 times, one for speeding up, one for slowing down. The first part, when I'm speeding up, my final is the 16.666, and the initial is 0, and we're dividing by the acceleration of 5. The second time we're doing it, everything is flipped, because now my final is going to be 0, and my initial is going to be 16.666, and my acceleration is going to be negative 8. So when we do these, we get the time at the beginning, and we get the time at the end. So that startup time is going to take me 3.33 seconds to speed up, and the other one, 16.666 divided by 8, is going to give me 2.08 seconds to slam on the brakes. Now, to find the time in this part, we are traveling at a constant speed. So again, all we have to do is say, well, V equals D over T. So again, these two are going to trade places. So I'm going to have T is equal to D over V. Well, we know that V is just my top constant speed of 16.666 meters per second, but I don't know what my D is. Now, I do know that this entire distance is 300 meters, but I don't know how big this distance is, the distance that I'm doing this. So first I have to figure out how much distance did it take me to accelerate to my top speed, how much distance does it take to slam on the brakes and come to a stop. So for that, we're still going to use that same concept where I have V initial, I have A, I have V final, but this time we're looking for D. So if I'm going to use these equations, that comes down to our last formula where we had D equals VF squared minus VI squared over 2A. And so we're going to have very similar numbers to what we had in these equations, except we have to add some squares. So really, if I just add a square here and a square here and an extra 2 down here, I have the same numbers that, oh man, excuse me. I have the same numbers I was dealing with there. And so I can use these same numbers to find out the distances. So if we do that, I get at the top that this was 27.8 meters. And at the bottom, this turns out to be 17.4. So, of course, this is chipping away at the edges of my 300 meters. So now I have 300 meters minus the 27.8 minus the 17.4 gives me 255. So if we have 255 meters left, that's what we're cruising here at our cruising altitude. So the D on top here becomes 255 divided by my 16.666, and that gives me a time of, from once I got to my cruising speed and I cruised along before I had to slam on my brakes, a time of 15.3 seconds. So now I just have to add up this time and this time and this time, and that should give me my total time of 20.71 seconds, which of course I only have realistically here 2 sig figs, so we're going to run that off to 21 seconds. Wasn't that fun?